in this problem, we throw the switch and see what happens. It's got a battery with an EMF. It's got 3 bulbs that each have the same resistance because they're identical bulbs, and a switch here. And the question is, when you throw the switch, which of these happens? A, the voltage across A is unchanged. The voltage across B goes to 0. Voltage across A up by 50%. Voltage across B down by 50%. So rather than trying to just sort of, I mean, you might be able to intuit some of those, but we're just going to walk through and think about the voltage across every element, both open and closed. I think that's the best way to approach it. If you had time on the exam, that would be the way you'd want to do it. So let's do delta VA, delta VB, and delta VC, and let's do one that was opened, and then what happened when it was closed. And we'll even analyze it like a proper circuit. So let's look at the case where it's open. That's the case we see here. Well, I would start by thinking about the equivalent resistance. We're going to let them all have a resistance of R. All right. So the battery sees REQ, right? So we got to figure out what is the equivalent resistance of the whole thing. Well, it's this in series with those two. So it's R, right? That's actually due to A, plus 2 resistors in parallel. So you could write that like this. Right, well, that's really B and that's C. So you've seen that kind of a combination before. You know, this is 1 over R plus 1 over R is 2 over R, but then we invert it, it's R over 2. So this branch has a resistance of 1/2. Oh, I forgot to put this resistor in. Let's put that one in. There are wires there, there's a switch there, but its resistance is infinity because it's an open circuit. It's an open switch. So this one, who is also in parallel, 1 over infinity is 0, so that doesn't do anything. So 1 over R plus 1 over R is 2 over R. Flip it over, it's R over 2, and R plus R over 2 is 3/2 R. So there is the equivalent resistance. Therefore, we now know the current flowing out of here, V equals IR, so it's the EMF over that resistance, EMF over 3/2 R, or it's 2/3 EMF over R. That current flows through that resistor, so we can figure out delta V for A. Delta VA equals the I, it has 2/3 EMF over R times R. So we can see that delta V across A is 2/3 of the EMF. 2/3 EMF. These two, so I would probably use the loop rule to get these. And I would see that since it's the wires on this side are all touching and wires on this side are touching, they have the same potential. So if we loop through either one of them, like that, or if we loop through this one, we should get that the potential around the loop is 0. So a quick loop rule tells us that plus EMF went over the battery, minus 2/3 EMF going across that bulb, minus delta VB has to equal 0. So you can tell delta VB has to make up the final third of the battery's EMF. So that's why it's 1/3 EMF, and delta VC is going to have the same value because they both have a wire on each side. Okay. That's when we had it open. Now let's close it. C-L-O-S-E. Let's see, when we close it, let's do the exact same thing. REQ equals R, that's A, plus 3 things in parallel. 1 over R plus 1 over R plus 1 over, and now this is a wire. Its resistance is very low. In fact, we could put 0, like that, and minus 1. And what is 1 over 0 is infinity. So I don't care what these are, this is infinity. So the thing is infinity, and you flip it back over and it's 0. So this is equal to R plus 0, which is equal to R. What this is telling you is this branch is really doing nothing. The equivalent resistance is this bulb. And that matches what you would expect. If we have a wire here, we've shorted out these two. Current will all go through the low resistance wire. Essentially all. So we really just have one resistor in this circuit, and that's what our equivalent told us when we thought about the wire. So let's get delta VA real quick. Delta VA is I. Oh, I'm sorry. Let's get the current I equals the EMF over the equivalent resistance, which is just R. So that's the current going through, and now we get delta VA. We're doing this in painful detail. Equals I EMF over R times R. Meaning all the EMF drops across this bulb, right? All your drop is here, no drop here, because it's just a wire EMF. What about the voltage drop across B and C? Well, I basically apply the loop rule and say plus EMF here, minus EMF here. The loop rule is done. There is no potential drop across these two because there's a wire going all the way around them. So these two go to 0. Now that we have a little table filled out, we can answer the question. A is unchanged. No. A changed. B went to 0. Yes. A went up by 50%. Yes. And that is true. 2/3 of the EMF, half of that's 1/3, so 2/3 plus 1/3 is a full EMF. Oh, yeah. And B went down by 50%. No, B went to 0. It went down by an infinite percent.